network, we have to find what is the potential of, absolute potential of A when this point is earthed. So over here, battery has a voltage of 30 volt. If battery has a voltage of 30 volt, it means across these 2 points, if we take it as X and Y, so potential difference across X and Y is 30 volt, whether we take this path or whether we consider this path or whether we consider this path. As we did earlier, we will not get confused. That is, the current comes from here, the conventional current flows in this direction, some current goes in this direction, then gets into the earth. If some current gets into the earth, then certainly the current in this arm will not be the same as the current in this arm. So as a result, the current which shall be going back to the battery will be lesser than what had been coming out of the battery, and this is not possible. The battery will always maintain its electrical neutrality. Whatsoever current goes out of the battery, the same current should enter into the battery. Whatsoever charges they are pushed into the circuit, the same amount of charges they should get into the battery at the same instant. So over here, for a time being, as we did earlier, forget this for a time being, and let's find the potential difference across the various resistors. We see that is potential difference is across XY is 30 volt, and we see that is 10 and 20 ohm, they are in series. So if we say the current in the upper arm is I1, if you look at the upper arm, we say, and we use V is equal to I into R. V is what? Across X and Y is 30 volt, I is I1, R is 20 plus 10, that is 30 ohm. So I1 is equal to 1 ampere. So in this, 1 ampere current flows in this direction. And this 1 ampere will be flowing through the 10 ohm resistor also and 20 ohm resistor also, and then it will be coming over here. If we look at the lower arm, which has 20 ohm and 10 ohm resistor, so over here we say I2. On the same lines we can use once again V is equal to IR. Now it is going to be I2. V is going to be what? 30. Potential difference across these two resistors, 30. I2 into 20 plus 10, that is 30. So I2 is also going to be 1 ampere. There is common sense also. The upper arm has also resistance of 30 ohm. The lower arm also has a resistance of 30 ohm. That doesn't matter, that is which one is first. First is 10 ohm or 20 ohm, that doesn't matter. As far as the resistance, the combined resistance of these two is going to be 30 ohm. So in this also it is going to be 1 ampere. Now how we can find the potential of A? Over here, that is as we did earlier, we have been given the reference potential, absolute potential of this point 0 volt. What we can do is, from here we can find the absolute potential of this point, and from here we can find the absolute potential of this point. Let's see how we do it. We find what is the potential difference between this and this. So 1 into 10, 10 volt is the potential difference. So 10 volt is the potential difference between this X point and this point, which has been earthed. Similarly, V is equal to IR. This is 20 into 1. 20 volt is the potential difference between X and A, X being at a higher electric potential as compared to A. The current is going from here to here, so it means the X it has a higher potential as compared to this 0 volt. So if this is at 0 volt, X is 0 plus 10. So 0 plus 10. So this is at an absolute potential of 10 volt. The potential difference between X and A is 20 volt because the conventional current is going in this direction. So potential of A is 20 volt lower than X. So VA is going to be, what's the potential of this X? What is that? It is plus 10. Minus, how much lower to X? It is 20 volt. Minus 20, that is minus 10 volt. So absolute potential of A is minus 10 volt. We could have also gone this way also, that is this is at 0 volt. Let's find the potential of Y. We know current in this arm is 1 ampere only. 1 ampere goes like this. 1 ampere is in this. So 1 ampere goes in this. So 1 into this 20. So 1 into 20, that is 20 volt. Potential difference is 20 volt. So if this is at 0 volt, so this is 0 minus 20. So the potential of, absolute potential of this Y point is minus 20 volt. Over here we see that a conventional current is going in this direction. So potential of this is higher as compared to this, and the potential difference is, current is 1 ampere, 1 into 10, that is 10 volt. That is VA minus VY. Conventional current is going in this direction, so potential, absolute potential of A is greater than the absolute electric potential of Y, VA minus VY is what? VA minus VY is 10 volt. Do we know the value of something, V or Vy? We know the value of Vy, that is minus 20 volt. So VA minus 10 is equal to minus 20 volt. So VA minus 10 is equal to minus 20 volt. VA is equal to minus 20 plus 10, that is minus 10 volt. Once again, we get the same value. So the absolute potential of point A is minus 10 volt.